All right, so here's what I've gathered so far from, exploring the math behind cosine similarity. Essentially, we know that words or phrases are going to be vectorized, which means they're going to be turned into numbers, which means something, right? And this is done because words themselves are very unstructured. So, to an AI algorithm which thrives on like rules and math, it becomes really hard for you to have just raw text because raw text is very fluid. It can change, and it's up to the perception of humans of understanding it, right? So that's why we turn it into numbers. And cosine similarity is basically used to figure out the direction between two different vectors. So it doesn't need to be in the AI space, though we are applying it within AI. It could just be a mathematical thing, right? It's a mathematical concept, which just means two different vectors. Remember, a vector is direction plus size. And essentially, it just finds the similarity in the direction between these two vectors, right? An important thing to note is that it actually does not take into the consideration of the size. So the size could be whatever you want. All right. But what we'll do, and you'll notice this when we go through the math, it actually normalizes another calculation, which basically takes away the magnitude or the size from consideration. All right. Now, another thing to note is that direction represents the semantic meaning of the phrases. So this is just more into the consideration of when we're using like OpenAI or like ChatGPT's like embeddings, right? Those vector embeddings, the direction really tells us a lot about the semantic meaning of the text compared to another vector. Now, this is the formula over here. It's using some sigma notations, which is basically just summing things up. And that's needed because you could have a lot of dimensions for your vectors. Your vector isn't constrained to using like 2 dimensions or 3 dimensions. It could be something as crazy as 1536, which is coincidentally the amount of dimensions, the vector embeddings that the ChatGPT embedding model generates, right? So this basically just allows us to calculate or allows us to take into consideration all of those embeddings by essentially starting out one embedding and then going up by the amount of them. Starting off with 1 dimension and going up with how many dimensions we have. So this basically takes into consideration the amount of dimensions, not embeddings. So we don't really care too much about the math, to be honest. It's just kind of having that conceptual understanding and just high level overview of it. You should be fine, right? We use a dot product, so that's the thing we're kind of using to determine cosine similarity. But that, right, is going to be divided by the sizes. So these are used to find the magnitude of your two vectors because you're comparing two different vectors in cosine similarity. And so that's the normalization part, which basically takes away the effect that the size of the vector has. Because dot product by itself will change based off of the size of the vector. But the size of the vector isn't really an accurate representation to the semantic meaning of that specific vector. Now, an important thing to understand, and this is really why I kind of did the math part and trying to understand all that, going through working up a theorem, which I'll do later on. But the reason for that is because I came to this conclusion, which it just states that to use cosine similarity, it only is able to take two vectors. Now, if we're looking at it in our specific application where we want to have a specific phrase or a specific text, and we want to compare that to, different examples or different documents for different political concepts and see how relevant it is to that, right? Compare that. So you could have something for the economy, something for immigration, right? uh, just having your only one vector as a reference point for all of these phrases, right, which the system will take in, that would be a very inaccurate representation of the actual system, right? Because the system should have way more examples, right? It should have way more vectors that are used as examples for different political concepts. And that's why I'm actually going to design a system where you're going to have multiple vectors, right? Vector embeddings that are used as examples, right? But I'm going to find a way. So this is an action item which I need to still do because it is getting late right now. I need to find a way to average these reference vectors to get basically a centroid vector. This vector, which essentially takes into consideration, to basically simplify it, it takes into the consideration all of the reference vectors for a specific political concept. So, for example, let's say you were talking about economy. And so in economy, you could have different vectors, like, let's say, a vector for the phrase stock booming, right? Obviously, it would be way more complicated in a real world scenario, but I'm just making this a bit simple. You could also have Wall Street good, right? Something like that, right? So let's say in this case, two examples were more than enough. So essentially, I need to find a way to average these two vectors so I get this one centroid vector which I can simply plop into this cosine similarity formula, and obviously I have like a libraries which will abstract this within the code itself. And then that's how I'll be able to get the similarity back, which will tell me everything I need to know. Now another thing to understand, so that's something that I need to do still, but it's just I wanted to explain sort of the design that I'm kind of going for, and the intuition behind it, right? So again, the reason why I'm doing this, I actually haven't explained that. So the reason why I'm doing this, finding the average of all these different reference vectors instead of just having this one big vector embedding, which all of my phrases would compare to, is because when you have this one big vector, well then the nuances that are present will be less like considered, and that's because the actual text is more general, right? It's more broad rather than being more narrow when you specify it to only like a couple of sentences. So that's kind of the reason why I want to find like the average average of these reference vectors in some sort of way which makes sense, which would give us our centroid vector, right? Obviously this is all very high level, and I don't fully even understand, to be honest, how I'm going to do this, right? Where I'm going to keep the all of the meaning the same, but I'm just going to figure out a way to get a centroid vector from all of the vector embeddings that we have, so that it keeps the nuance and depth that is present in these very narrow and specified text embeddings, essentially. But yeah, that is going to be a challenge that I need to figure out tomorrow, right? Okay, the one thing I was gonna say though is that the cosine similarity is literally just the cosine. It's just the cosine between the angles of two different vectors, right? But figuring out the angle theta would be a little bit difficult, so that's why you use this formula instead, right? Because then you only really need to know the size of the vectors, which the AI model already knows, right? Or sorry, the dimensions of the models, right? Not the size. The size is computed through these. Yeah, so that's one thing that I really wanted to bring out, the fact that we need this architecture or this system to figure out the average reference vectors, and then that gives us this centroid vector, which is basically this one averaged out vector. I try not to say average that much because it's not really going to be like an actual average, like you would take an average of your grade, but rather like a method which allows me to keep everything that I need, right, within the depth and nuance, as I said before, but it's only one vector, so I can actually put it into the similarity, calculation or computation. Then I'm just going to make a diagram of what I just talked about right now, right? I'm going to have AI summarize all of this too. And so then I'm just going to have this diagram of the system design that I have, especially this first part of finding average reference vectors to get that centroid vector. Again, I don't know the formula. I'm going to figure that out, or like the method. I'm going to figure that out tomorrow. But yeah, and I'm also gonna do like a full math work with like, first figuring out the centroid vectors for the reference vector embeddings for each political concept, and then employing the cosine similarity to figure things out. And I'll use like a simple example, just so that we see it on paper and we see it through just our thoughts. So that's kind of why I do this part, just to help me, so that like when I start coding, I can code with proper intent. And that's something I'll also start tomorrow. Most likely not finish tomorrow because I have a lot of other things and some schoolwork. But I will definitely